So let us have a quick revision what we have learned in the previous class. So we have seen what is the scope of this subject, engineering mechanics, what you are going to learn in this course, and what are the course objectives and the course outcomes of engineering mechanics. Also, we have seen the importance of this subject for a student belongs to any other branch of engineering. In addition, we have also learned that what is engineering mechanics, what are the various branches of engineering mechanics. So now what is engineering mechanics? Can anyone tell me what is engineering mechanics? Mr. Mohit Dolani, roll number 52.
Hello.
Yes.
The branch of mechanics will deal with the study of rigid body under action of applied forces.
Very good. So it is a branch of engineering, which deals with the study of behavior of rigid bodies, right? So what is rigid body? Mr. Vaibhav, roll number 2.
Rigid body means where deformation is zero.
Okay. So when a force system is acting on a body, and if the deformation of that body is 0, then it is known as rigid body. Other way around, any body can be considered as a rigid body if the deformation of that body is very, very small as compared to overall dimensions of the body. Right. Then what is statics? So engineering mechanics is broadly divided into two parts, statics and dynamics. So what is statics? Renuka, roll number 6.
Sir, it is study of mechanics which deals with bodies at rest.
Very good. So statics is the branch of engineering mechanics which deals with the study of behavior of rigid bodies when they are at rest. Okay. Similarly, what is dynamics? It is the branch of engineering mechanics which deals with the study of behavior of rigid bodies when they are in motion. So dynamics is further divided into two parts, kinematics and kinetics, right? So what is kinematics?
Sir, the branch of mechanics where we deal with the motion of the object by not considering the forces and all.
By not considering the forces. Very good. So it is the branch of engineering mechanics which deals with the study of behavior of rigid bodies when they are in motion but without considering the forces causing the motion. Here we are interested in how the body is moving but not why it is moving, right? Then what is kinetics?
Sir, kinetics is the study of reaction rates.
Study of
Reaction rates and how they are affected.
reaction rates. So can you elaborate? Can you give any one example? What do you mean by reaction rate?
Sir.
Yeah, what is kinetics?
So kinetics we just discussed.
Repeat.
Sir, it is the study of bodies, rigid bodies, which are in rest, but not without application of external force.
That is kinematics, no? First of all, it is not at rest. Kinematics and kinetics deals with the bodies in motion, right? So if you are not
Yes, sir.
considering the forces while analyzing the motion of the body, that is kinematics. And if you consider the forces also, then it comes under kinetics. Means while analyzing the motion of the body, we are interested in not only how the body is moving, but also why it is moving. The forces which are responsible for the motion of the body are taken into account while analyzing its motion. That is kinetics. Okay, is it clear? Then moving to idealizations in engineering mechanics.
Yeah.
So what are these idealizations? Simply, idealizations are nothing but assumptions. Okay. So why these assumptions are made? To make the analysis more simple. And in engineering mechanics, basically, there are three idealizations which we are going to study. One is particle. What is the theoretical definition of particle? So theoretically, particle is defined as an infinitesimally small part of the body. Am I right? Means there is no particular size or shape for the particle. The concept of particle is very similar to that of a point in geometry. See, the point has location, but no dimensions. Similarly, particle has mass, but no dimensions. In engineering, we can consider any body as a particle if the dimensions of that body are so small that they can be neglected. Are you getting my point? So it is assumption, idealization. So if we are neglecting the dimensions of the body while analyzing that problem, then we are calling that body as a particle. Is it clear? So we will study in detail about this particle body in the next slide. Then rigid body. It is already studied. So rigid body is an idealized concept because in the universe there is no body which is 100% rigid. All bodies are deformable bodies. But for practical purposes, if the deformations of the body under the action of applied forces are very small as compared to the overall dimensions, we are neglecting those deformations, saying that the body is a rigid body. Okay. Then, point of application of force or concentrated force. See, when the force will develop or when it will be created, when there is an interaction between the two bodies, then each body will exert a force on the other. So the force is going to be created through an interaction between the two bodies, right? So whenever I'm saying the interaction between the two bodies, that interaction takes place through some contact area between the two bodies. If that contact area is very small, then we can assume that a particular body is applying or exerting a force on the other body at a particular point. Got it? No. Let us see an example regarding the particle first. There are two pictures here. So in the first picture, the earth is rotating, it is rotating about, revolving around the sun, right? And also it is rotating about its own axis. There are two types of motion. It is rotating about its own axis. At the same time, it is moving around the sun in a particular orbit. So while studying the motion of this earth around the sun, we can treat that this earth as a particle, because as compared to the diameter of the orbit in which the earth is rotating around the sun, the size of the earth is very, very small. So while analyzing the motion of the earth around the sun, we can treat that earth as a particle, neglecting the size of the earth. But when you are studying the rotation of the earth about its own axis, then you have to treat that earth as a body, right? The moment I am saying body, the rotation will come into picture. While analyzing this motion of the earth around the sun, that rotation of the earth around its own axis can be neglected, because the effect of that rotation on the motion of the earth around the sun is negligible. Are you getting my point? So while studying the motion of the earth around the sun, we can treat the earth as a particle. At the same time, while studying the rotation of the earth about its own axis, we have to treat that earth as a body, right? So earth is considered as a particle over here, and here it is considered as a body. Then rigid body. See, when forces are acting on a body, if the distance between the particles constituting that body, in other way around, the size and shape of the body is not changing under the action of applied forces, then that body is considered as a rigid body. Now see here, for a point of application of force or concentrated force, a person is standing on the floor. Say weight of this person is 51 kg, for example. That means it is approximately 500 Newton. Now this person is exerting a force on the floor. There is an interaction between the floor and this person. That interaction is taking place through the area of contact between his feet and the floor, right? So his entire weight is acting on the floor through the area of his feet. But as compared to the area of this floor, area of his feet is very less, very small. So we can assume that the entire weight of that person, 500 Newton, is acting at a point. The point is nothing but the centroid of the area of his feet. So it is assumption. So in reality, the force will never act at a point. Remember, if the force is acting at a point, that body cannot resist that force. That force will pass through that body. So in order to resist the force, it has to act over some area. But for practical purposes, if that area is small, we can assume that the entire force is concentrated or acting at a point. And this force is known as concentrated force or point load. Right? So this concentrated force is idealized concept. Okay. Then let us have a small quiz. Engineering mechanics deals with the study of. So engineering mechanics deals with the study of rigid bodies. Very good. Then the branch of mechanics which deals with the study of rigid bodies which are in motion is known as this.
So dynamics.
Which are in motion is known as dynamics. Very good. Then kinematics deals with the rigid bodies in motion.
Sir, B, without considering the forces.
Right. Without considering the forces. Next, while analyzing the motion of the body, if we consider the mass of the body, then that study belongs to
Kinetics.
What's your name?
Atharva Kulkarni.
Other. So while analyzing the motion of the body, if we consider the mass of the body, that means we are considering the gravitational force.
Yes.
That comes under kinetics.
Kinetics.
Nice. Next, which of the following are considered as idealizations in engineering mechanics? Option D, all of these. Now, a body is considered as a rigid if size of the body is neglected, deformation of the body is neglected, rotation of the body is neglected, or none of these.
Thank you, sir.
Because if the size of the body is neglected, we will treat that as a particle. So also, if the rotation of the body is neglected, it becomes a particle. Because in a particle, being the size is neglected, whatever the forces are acting, all those forces will pass through a point, right? Then that point or particle will have only translation. And suppose on a body, if a force system is acting in such a way that that force system is not having any tendency to rotate the body, then it becomes a particle. Is it clear? That means while studying, while analyzing the problem, if the rotation of that body is neglected, then it becomes a particle, right? So the body is considered as a rigid only if the deformation of the body is neglected.
Okay, sir.
So answer B. Then we will see in detail about these basic concepts like particle and body, rigid body and deformable body, one-dimensional, two-dimensional and three-dimensional bodies, and what is mass and weight. Let us see particle and body. So the theoretical definition, particle is infinitesimally small part of the body, whereas the body is composed of infinite number of particles, right? The concept of particle is very similar to that of a point in geometry. Point has location but no dimensions, as well as particle possess mass but no dimensions. Simply, particle is nothing but a concentrated mass, whereas in body, the matter is limited in all directions. Okay, so in any problem of mechanics, when as I said earlier, when all the applied forces which are acting on that body have no tendency to rotate the body, then that body can be considered as a particle. See, there are two bodies over here. The first one also I am treating it as a body, right? Though the size is small. A force system is acting on this body. So 5 forces are acting. F1, four. F1, F2, F3 and F4. But the lines of action of all these forces are passing through a common point. Whereas here in the second case, the 4 forces are acting, but the lines of action of these forces are not passing through a common point. So here, what will be the resultant of this force system? In first case, it will have a resultant force, right? So it is concurrent force system. So all these 4 forces will have a net force, nothing but resultant force. And what is the resultant of the force system in second case? Being the lines of action are not passing through a common point, so this force system will have a resultant which includes resultant force and the resultant moment. This moment is coming into picture because the lines of action of these forces are not passing through a common point. Is it clear? So what is the effect of this resultant force on the body? To produce translation. The body tends to move in the direction of that resultant force. So here it is having only translation. Here, what is the effect of this resultant force and resultant moment on the body? Because of resultant force, it will have translation, and because of this resultant moment, body will have rotation also. Means in this particular case, second case, the body is having translation as well as rotation. The moment we are saying there is a rotation, so it refers to a body, because the particle does not have any rotation. So particle undergoes only translation. Now see one more example. Here there are two cars. In the first case, I am neglecting the size of the car. So I am treating that car as a particle. Then say W is the weight of the car. Then this road will offer a reaction, right? Because of this weight of the car tends to move vertically down. Am I right? In order to balance that, road will offer a reaction having same magnitude in the opposite direction to maintain equilibrium. Being here, I am neglecting the size of the car. I am treating this car as a particle. So you will have a reaction from the road R in order to balance this W. Whereas in the second case, I am considering the dimensions of the car. So the distance between these wheels is say 2.5 meters. Now, as I am considering the dimensions, then here the reactions offered by the road are R1, R2. Because R1 is the reaction from the rear wheels and R2 reaction from the front wheels. Am I right? As I am considering it as a body, means I am considering the dimensions of the body. Here I am neglecting the dimensions, here I am considering the dimensions. So in particle, dimensions are neglected, whereas in body, dimensions are considered. The most interesting example, fast bowling and spin bowling in cricket. So in fast bowling, while studying the motion of ball, we can neglect the rotation of the ball, because the rotation of the ball is having negligible effect on the movement of the ball as compared to the force with which we are throwing the ball, as compared to the velocity with which it is moving, displacement that it has traveled. The rotation of the ball is having very small effect on that. So we can neglect that rotational effect. That means we are treating that ball as a particle. We are neglecting the rotation. If the same ball is thrown by a spinner, then while analyzing the motion of the ball, we have to consider the rotation. Spinning means rotation of the ball, right? So in fast bowling, we can neglect the rotation, hence we can treat that ball as a particle. Whereas in spin bowling, while analyzing the motion of the ball, we have to consider the rotation. That means we are treating that ball as a body. Understood? Depending on the physical situation, we can consider whether the given body as a particle or it can be treated as a body. So here in fast bowling, it is having only translation. Of course, small rotation is also there, but we are neglecting that. So we are saying it is having only translation. So as it is a particle. Whereas in spin bowling, it is having translation as well as rotation. We are considering the rotation of the ball. At the same time, translation from one place to another. So the body is having translation as well as rotation. Again, coming back to the same example. Here, depending on the physical situation, the given body may be treated as a particle or as a rigid body or even as a deformable body. For example, in the computation of the motion of the earth around the sun, the earth may be accurately modeled as a particle. While studying the motion of this earth around the sun, you can model the earth as a particle. Since the rotation of this earth is having very small effect on the motion around the sun, am I right? Similarly, with respect to the rotation of the earth about its own axis. The earth can be modeled as a rigid body, since the deformation of the earth has very small effect on its rotation. So we can treat this earth as a rigid body. However, in the determination of the shape of the earth's elastic and plastic deformations must be considered. That the earth can no longer be assumed as a rigid. See, here there are three different cases. While analyzing the motion of the earth around the sun, we can treat that earth as a particle. While analyzing the motion of this earth around its own axis, we can treat that body as a rigid body. But while determining the shape of the earth, we have to treat that body as a deformable body. So depending on the physical situation, we can consider whether the given body as a particle or a rigid body or a deformable body. Okay.
Sir,
Yes.
so if it's a deformable body, so we'll be considering it particle or anything according to situations, right?
If it is a deformable body, then there is no question of particle. The moment you are saying body, whether it is a rigid or a deformable, you cannot
Okay, but
treat
it's still a
that as a
body.
particle. Yes.
Yeah, okay.
Right. So a body can be considered as a particle. Point to be noted. If the overall dimensions of the body are so small that they cannot change the behavior of that body and hence can be neglected. So that is the definition of particle in engineering mechanics. It is an idealized concept. Simply, it is an assumption. Okay. So particle, it is infinitesimally small part of the body. Theoretical definition. Body, it is composed of infinite number of particles. Particle do not have size and shape, right? Whereas body, it is having definite size and shape. Particle undergoes only translation. There is no rotation. Body undergoes translation as well as rotation. Particle is nothing but point mass. Dimensions are neglected. Whereas mass is distributed over the entire body in case of a body. Simply, particle occupies point in space, whereas body occupies volume in space. Because in particle, we are neglecting the size, we are neglecting the dimensions, whereas in body, we are considering the dimensions. Then next, rigid body and deformable body. This we have already studied in detail, right? So let us consider two bodies. Let A and B are the particles constituting that body. Say D1 is the distance between the particles. Now you are applying a force system on both the bodies. So in the first case, in the first body, after applying these forces, the distance D1 is not changing. That means the size of the body is not changing. Therefore, it is a rigid body. Whereas in second case, the distance between the particles changed from D1 to D2. So there is a deformation. So it is deformable body. So a body can be considered as a rigid body if the deformations are very small, that is negligible as compared to overall dimensions of the body. The same thing here once again. The distance between the particles constituting the body does not change under the action of forces in rigid body. The distance between the particles constituting the body changes under the action of forces in a deformable body. In rigid body, the size and shape of the body does not change. As I'm saying that the distance between the particles constituting the body does not change, means the size and shape is not changing. Whereas in deformable body, the size and shape of the body changes under the action of forces. Now, what are one-dimensional, two-dimensional, and three-dimensional bodies? Generally, body is defined by its three dimensions. Are those length, breadth, and height or depth? So if all these three dimensions are significant, then we can say that the body is a three-dimensional body. So a three-dimensional body is the body in which all three dimensions are considerable. Now, out of dimensions, if any one dimension is very, very small as compared to other two dimensions, for example, as compared to the length and the breadth, the thickness or height or depth of this body is very, very small. Am I right? So you can neglect being it is very small as compared to other two dimensions. Now this body can be called as a two-dimensional body. The moment you are saying body, it is defined by its three dimensions. But being the third dimension is very small, we are neglecting that, saying that body is a two-dimensional body. So a two-dimensional body is the body in which two dimensions are very large as compared to the third dimension. Any example for two-dimensional body? Say metal sheet. As compared to the length and breadth, the thickness is very small. A sheet of paper, it is a two-dimensional body. The thickness of paper is negligible as compared to the length and breadth. So it is two-dimensional body. So this two-dimensional body is also known as lamina. Point to be noted. Lamina means it is two-dimensional body. Similarly, one-dimensional body. Out of three dimensions, if any one dimension is very large as compared to other two dimensions, out of three, only one dimension is very large. That is one-dimensional body. So here the length of the body is very, very large as compared to the cross-sectional dimensions. That is the breadth and depth. So we can call this as a one-dimensional body. Means when forces are applied on this body, the changes are going to take place, the significant changes in one dimension only. That is nothing but along the length. And whatever the changes are taking place across the cross-section, so those changes are negligible. Hence, we are calling this body as a one-dimensional body. So, any example? One-dimensional body is the body in which one dimension is very large as compared to other two dimensions. Metal rod, steel rod, as compared to the length, the cross-sectional dimensions are very small. So it is one-dimensional body. Metal wire, thin metal wire. Yes.
Pencil.
Right. As compared to the length, cross-sectional dimensions are small. Very correct.
Thread.
Right. Rope.
Wires.
Right. Wire. All these are one-dimensional bodies. Now coming to the most basic thing, mass and weight. Anybody? Can you tell me what is the difference between mass and weight? Anyone?
Mass is constant, weight is not
right.
constant.
Mass is constant, weight is not constant. Very good. So what is mass? How do you define mass?
So mass is a fundamental quantity and weight is not a fundamental quantity. It is a derived quantity and it depends on the factors that is acceleration due to gravity or yeah, it means actually yes, that only.
Right. So
Sir,
mass, yes.
Sir, mass is the amount of is a physical property of a matter which determines the amount of content in matter.
Very good. So mass is the
Hello, sir.
quantity of matter. Yes. Yes, please.
Sir, mass is the measurement of the amount of matter in the object
Correct.
and is measured by gram and kilogram.
Right. Correct. So mass is the quantity of matter contained in a body, right? And it is measured in, as we said, grams or kilograms. Whereas all the bodies or particles in the proximity of the Earth's surface are subjected to a gravitational force exerted by the Earth, right, on the body, which is nothing but weight of the body. So the gravitational force exerted by the Earth on the body is the weight of the body. So the weight of the body changes from place to place as the acceleration due to gravity changes. So mass is the amount of matter contained in a body. Gravitational force exerted by the Earth on the body is nothing but weight of the body. It is constant everywhere. Mass is constant everywhere, whereas weight changes from place to place as acceleration due to gravity changes. It is a scalar quantity. Mass, weight is vector quantity. SI unit of mass is kilograms, whereas weight is measured in Newton. As per Newton's second law of motion, we know that force is equal to mass into acceleration, right? Here force, gravitational force, nothing but weight is equal to mass into acceleration due to gravity. W is equal to m into g. In our engineering mechanics subject, while doing the calculations, we will assume that the acceleration due to gravity g as 9.81 meter per second square. Okay, it is not 9.8 or 10. You, unless and until they mention, you have to consider g as 9.81 meters per second square for all the calculations. Quiz time. If the force system is acting on a rigid body, which is not having any tendency to rotate the body, then the body can be considered as a particle. Then, when a number of forces are acting on the particle, those forces necessarily will form a system of concurrent forces, parallel forces, either concurrent or parallel, neither A or B. System of concurrent forces. In engineering, the concept of particle is similar to that of a dash in geometry. Point. Very good. So the concept of particle is similar to that of a point in geometry. Next, if the deformation of the body is negligible as compared to overall dimensions of the body under the action of forces, then that body can be considered as good. If the distance between the particles constituting the body do not change under the action of forces, then that body is known as a rigid body. Then lamina is an example of two-dimensional body, right? Then if the mass of a person is 60 kg on the earth, then his mass on the moon is same as 60, right? Because it is independent of the gravity. It remains constant. If the weight of 100 kg person on the moon, if g is 1.625 meter per second square, g on the moon, weight is equal to mass into acceleration due to gravity. 100 into 1.625, so 162.5 Newton. So mass of the body is always constant, changes with respect to time, changes with respect to place, changes with respect to temperature. It is always constant. then weight of the body, it changes as acceleration due to gravity changes. You can't say even it changes with respect to place. Though the place changes, if g remains same, the weight of the body remains same. So it depends on the acceleration due to gravity. So some more basic concepts that we are going to see in the next class.